Hello, in this video I'll try to explain an assembly language program to multiply two numbers, and also I'll explain how to use Keil Microvision tool to develop and execute the program. So to use the Keil Microvision tool, you just double click on Keil Microvision shortcut. Now in this case, if any earlier project is already opened, you just go to project and close that project. If you want to create a new project, go to project, create new Microvision project and give the project name. I'll give program 2, okay, as a project name. It asks for the device. So here we are using LPC1768 microcontroller in our laboratory. Actually this device is from NXP company, so I have to choose the device from NXP company. The device is LPC1768. The description of the device is listed at the right hand side of the window. You can refer it out. Okay, click on OK, click yes and click yes. A target file will be created. Okay, within this target file there is a source group. In the source group, by default, startup file pertaining to assembly language is added, that is startup underscore lpc17x6.s. Suppose if you are developing your program in assembly language, this startup file is sufficient. If at all if you are developing your program in C language, you have to add a system file corresponds to C language also. In this example I am also writing C program, that's why I have to add that startup file corresponds to C program. So I'll go to add files to group source group 1. Then this C file, startup file pertaining to C language, is actually stored in C drive, because while installing the tool, by default it's going to locate at the C drive. So in C drive you search for a folder called Keil. Within the Keil folder you have to search for an ARM. Okay, in ARM there is one more folder called startup. In startup you have to go for NXP. There you have to select LPC17x6 and you have to see here LPC startup .s file is visible. If you just change the source file from ASM to C, so that system underscore LPC17x6.c file will be available here. Select it out, add and close. Okay, so that file will be listed under source group 1. Now let me create a new file. Go to file, select new file. So this is an editorial window where you can develop your program. Now I already have a program. I'll just copy paste it. Now this is a C program. So if it is a C program, you have to save that file as a file name with an extension .c. So I'll save this file as mltpy multiply .c. Okay, multiply.c. This is my file name. .c is an extension for C program file. Similarly, I am going to create one more file. There I am going to develop assembly language program. So the assembly language program should be saved with an extension .s. Okay, it's supposed to be saved as file name with an extension .s. I'll save it as 2_number.s. Okay. In assembly, the assembler directives and the instruction should be start after one tab space, whereas the label should be start at the initial point of the editorial space. Okay, this is the procedure for developing an assembly language. Okay, except entry point. Now let us look into the program flow. Here I have used a C program. So this C program is used to call a subroutine, that subroutine is written in assembly language. Okay, here I have included lpc17xx.h. This is an header file. So all the associated structure of LPC1768 microcontroller and necessary functions are under the structure lpc17xx.h. I'm going to declare a function mul2. It's an external function mul2. It's of void type. It doesn't return anything to the main program. This statement is initializing the main program. Now this is system initialization. It's an inbuilt function provided by CMSIS. It's a standard function to initialize the system. And mul2 is a function. This function or a subroutine is written in assembly language. The while one statement is written to indicate the no operation states. Okay, your program will be terminate at this point. Okay, so once your program flow execute mul2, the program control transfer from main program to a subroutine. Here the subroutine is written in assembly language. Here area product code read only is an assembler directive which is actually declares or which is going to reserve some memory area, is of kind read only code memory with the name of product. Okay, it is to reserve some memory area, read only code memory area, and the name of that area is product. Export mul2, this is a linker reference. Okay, export is an assembler directive again, which is a linker reference. So this linker reference is important when you want to, when the program is being called from the main program. Entry is an assembler directive which indicates the entry point of the program or where the first instruction is supposed to be executed. Mul2 is a label. A label should be always starts from the start point of the editorial window. Okay, here move r1 comma 03, it is a data transfer instruction where the immediate value decimal value 03 is loaded to r1. Similarly, a decimal value 2 is loaded to r2. And now this loop is a label again. Here since no loop is required, we can, it's not mandatory. If you want, you can add it out, otherwise you can remove. Just to show how to include the loop label, this instruction is this statement is written here. Now mul r2 comma r2 comma r1, this is a multiplication instruction where the operand r2 and r1 are multiplied and the result will be stored in r2. Here the register r2 acting as both source and destination. After execution of this instruction, the branch termination instruction is going to execute. So this instruction must be written whenever a program or a subroutine is called by the main program. So this indicates the end of the subroutine and your program control returns from subroutine to main program. Okay, and it's the end of assembly program. Okay, the end of the program is indicated by an assembler language end. Okay, this is about the program. So after execution of this instruction, the 2 into 3 6, that result will going to store in r2. Okay, after termination, your program control go back to main program and it will going to halt at this stage. This is about main program. Now let us add these files to the source group. To add that, right click on source group, add files to group, then select files. If I select a C file, it is multiply.c, mltpy.c, add, close it. Similarly, you add the ASM file also, that is .s file also. The file name is 2 underscore number.s. Since it is a source file as an assembly file, so you have to change the source file from C to ASM source file and select that file as 2 underscore number.s. okay, add and close. So all the files supposed to be executed are listed in source group. Now you have to perform build targets. Okay, right click on the target and click on build target, or else there is a shortcut available here. Okay. Now this returns with 0 errors and 1 warning. Let us see what's the warning. Okay, in C program, after end of the program, you have to enter one new line. Okay, it's mandatory. Now we will rebuild out. Okay, so it returns with 0 errors and 0 warnings. Now you Now we will going to perform a debug session, or we will going to debug this program. Go to debug, start stop debug session, click on OK. Now all the associated register will be displayed on the left side of the window. So and their initial value is also provided here. Now you can press F11 for step execution, means each line of the instructions will be executed. And initially the startup files are being executed. Okay, after these are all the instructions corresponding to startup file. Now after execution of the startup file, so the yellow arrow indicates the instruction or statement to be executed next. Here after execution of mul2, your main program is going to call a subroutine with the name called mul2. Now your program flow transfer from main program to subroutine. In this subroutine, the instruction to be executed is move r1, 03. Move r1, 03. Initially look at the value of r1. R1 have some default value, or its reset value. So after execution of this instruction, r1 is loaded with 3, and the next instruction being executed is move r2, 02. Initially r2 is loaded with some default value. After execution of this instruction, r2 loaded with 2. Now the next instruction being executed is multiplication of these two number. See, look into the initial value of the r2 is 2, and after execution of this instruction, the result of r2 and r1 is multiplied, and the result is stored in r2, and you can see that the value of r2 becomes 6. And after execution of this multiplication instruction, your control flow is going to execute branch termination instruction. So after execution of the branch termination instruction, the control flow or program flow go back to the main program where there is no operation. Your system is going to halt, this program is going to halt at this stage. So this is about the debug session, and we have to observe what's the value of the register before execution and after execution. Okay, that's all about the program flow and how to execute this program in Keil Microvision tool. Okay, you come out from start stop debug session, and suppose if you want to download the program to LPC1768 microcontroller, then it is necessary to create the hex file. In order to create the hex file, you have to right click on target and option for target, and there is a option called output where you have to check for create hex file. Okay, so if at all for all part B programs, that is software program, with the help of Keil Microvision tool, the built file should be created. That means hex file for the particular source file should be created, and that hex file must be downloaded to LPC1768 microcontroller. And also in linker, you just click use memory layout from target dialog, then click OK. Again you rebuild the target, so it's going to create the hex file. Okay, so this hex file can be downloaded to LPC1768 microcontroller. Thank you.